We try to do this for these tour groups to try and ensure we get the rides up on time, which we're supposed to open up at 10. Mr. James over there, what you're seeing him do right now is called a 5-minute pull test. What this is on a weekly basis, we put these boxes in here that are supplied by Gerslauer, and they are spring loaded to apply a certain amount of pressure to the restraint cylinders. Right now, we only have one restraint cylinder holding that restraint in place. What that is doing is applying that pressure to ensure that that restraint cylinder is working properly. It is going to hold for that 5 minutes. Now on a daily basis, we do a 5-second pull test on every single restraint, every single cylinder. 2 cylinders per seat. And it's a redundancy system. If one does fail, the other one will hold. In the time that I have been here, never seen 2 cylinders fail at the same time. It's normally one or the other. So the restraint cylinders on each one of these cars get changed out every 7 years. We are actually in the process of doing that as we're rebuilding vehicles this year. At this time, you see 5 cars up on dock. We've got one downstairs. Car number 5 is actually at our central shop right now, and it is in literal pieces. We tear the entire car apart, every nut and bolt, every component, every axle, every pin, everything gets torn down. Gerslauer then tells us through maintenance manuals what needs to be mic'd or checked for outside diameter or inside diameter, whichever one it is. We check all that. We do what's called NDT on it, non-destructive testing. That is a mag particle test on all of the weld joints, on the frames, on the bogies, on the axles, on the seat frames. Everything that has a weld on it, it's getting powder thrown on it to make sure that it is in good working order, nothing's broken or missing, anything like that. So we do full visual inspections every day on top of the 5-second pull test on each one of the vehicles. We're inspecting everything from the floor pans to the stickers, fiberglass, restraint arms, the seat elements, everything in there. We even look, Gerslauer is pretty cool, they put cutouts behind the seats to where we can look and actually see visually on the restraint cylinders to make sure we're not cracked, leaking, or anything of that nature. The cylinder's not damaged, the rod's not damaged, anything like that. So it is a thorough inspection on a daily basis. And then on top of that, we have then weeklies and monthlies that we have to do on the vehicles, on top and bottom end, which takes the inspection even deeper than what we do on a daily. So these vehicles get inspected very, very thoroughly, even on just a daily, even on a daily inspection as it is. So we have 4 hours to get all of our vehicles inspections, tracked, inspected, and everything, and it's fun. We are moving, you can ask Mr. James over there, we are moving pretty quickly to achieve this goal while doing a thorough inspection. So we're constantly moving. We don't have much downtime to where we sit around and do nothing in the mornings. So that's one thing operations says, y'all just sit around and do nothing. That ain't happening. So, but every day, everything on the ride gets inspected. On a weekly and monthly, we do a deeper inspection on stuff to ensure everything is running properly. We do function tests on everything. As you can see, we raise the restraints, lower the restraints. We make sure that the PLC is seeing the restraints come up, the restraints come back down. If the PLC does not see one of those 2 things, it will not ship the car because it does not know the configuration of the restraints. And the way it knows the configuration of the restraints is actually on the restraint arm, just beside the restraint arm, is actually a limit switch with a cam that comes down while the restraint comes down. So we have to manually adjust those cams, or manually adjust the proxy to the switch to ensure that we are not any bigger than 400 millimeters on the close of the restraint. If we go past 400 millimeters, we're in trouble. We cannot go past that 400 millimeters. That is dictated by Gerslauer. So on a weekly basis, with the boxes, we will then check the opposite row. So he's already done the front row, but we'll check the opposite row to ensure that we are under the 400 millimeters. Normally we try and like to keep it between 380 and 400. Give us that little bit of wiggle room. And that doesn't affect too much on the guest on there, because adjusting that limit switch to get that exact 400 millimeters is like splitting hairs. It's not easy at all. So it takes a good amount of time. You'll adjust the switch, bring your restraint down, get your green lights on the back side of the seats. Once you get your green lights on the back side of the seats, then you check your gap. A lot of times on the first adjustment, we'll either be too far in or still a little bit too far out. Make adjustments again. It's back and forth, but we ensure that we are underneath that 400 millimeters. Oh, sure. Yeah. So like I was saying earlier, this is the restraint box that we use. This little guy, like I said, comes from Gerstlauer. Dropline uses them as well. So, and actually Dropline, if you look at their seat elements, the part that you sit in, it's the exact same seat. They purchase the same stuff and whatnot. The actual restraint cylinders on Mystery Mine are exactly the same on Dropline as well. So a lot of parts can be interchangeable. We do not. If it was given to us by Gerstlauer, it goes on here. If it was given us to by Fun Times, which is Dropline's manufacturer, it goes on Dropline. So, but there are, if you look at these rides, such as Fire Chaser and Mystery Mine are both Gerstlauer rides. Some of the components are interchangeable. We do not. If it was made for Fire Chaser, it stays over there. If it's made for Gerstlauer or Mystery Mine, it stays over here. So you're actually, that's the gauge that we use in order to check our 400. This first step right here, that right there is 400 millimeters. Second step is 380. Last step is 360. We like to keep it tight on here, loose on here. If we can keep it in between those two, we're getting the maximum amount of guests per their size on the ride to get them to be able to ride. So that's one reason why we have the test seat downstairs, so you don't have to do the walk of shame when you are a little on the huskier side and cannot fit in the restraints.
What about tall?
On here, height is not too much of an issue. The restraints are actually pretty up pretty high. Wild Eagle, on the other hand, does, is it Wild Eagle? Wild Eagle does have a height restriction on it. I don't think does Dragonflyer? I can't remember because that's not one of my rides.
He's
yes.
right at the height restriction for
there you go.
Wild Eagle.
But for here, not really. I mean, you would have to be 7 foot, maybe 7'5" before the restraint wouldn't come around your shoulders when you're doing this right here. That wouldn't be fun. So, but this is what Dollywood considers a high throw ride. It does pull a good amount of G's. It also gives you negative G's. Outside on the backside here, you see the track. That's an inline hard corkscrew with a 0G flip on the end of it. When Gerstlauer manufactured this, it was one of the first ones that they did that combination to. Really cool. Mr. Mine was also one of the first ones that, if I'm not mistaken, that also had a 95-degree drop, to where the drop actually came back in on itself. Now Gerstlauer manufactures them with 125, 145-degree drops back in on itself. Really cool designs. I really like it. So, any questions on what we do on the top end for inspections on this?
Do you guys do a lot of inspection for like the show elements, or is that
for the
like the actual show elements?
Yes, those are on it. They are not safety critical. This all stuff here is safety critical for us. Show elements are not. So if we have a theming element down, such as the light bulb above y'all's head right there, and that lantern is actually burnt out, we need to change that. It's not a showstopper.
Okay, so
No, it's ambiance.
Exactly. It's a mine. They're not always working. But that
there's sometimes fire and sometimes there's not.
Correct. That is something actually our control electricians are working on. It's not a mechanical issue. It's actually the flame effects at the top of lift 2 at brake 8 actually has its own little PLC up there controlling it. So that's their world, not mine. I fix this stuff. So, but any other questions?
Yeah. Do you ever like periodically do bumping tests?
We prefer not to bump the cars.
Right.
So
Do you ever? like test it just to?
No, ma'am.
Okay.
We prefer not to bump the cars. It does happen from time to time accidentally. We do not want that because that could damage the vehicles. Yes, it has bumpers on them. We do not want to test that theory out. So, somebody else had a question? Yes, sir?
So how do you track your maintenance?
Say that
How
again?
do you track it?
So we have a system that we just switched to over this year called Mobaro. Mobaro is an online inspection process. So all of our inspections that is dictated by Gerschlauer for a daily, weekly, monthly, semi-annual, and annuals are all on those. And on a daily basis, we are actually doing all of our inspections on Mobaro, and I can go back into the system and see and track and say, hey, we're seeing excessive, we're changing this out a lot. Let's get with Gerschlauer and see if we can, see if they've got a different design for this or something, to where it will extend the longevity of the item. So that's how we do our tracking on there.
Does that also let Gerschlauer then see your results as well, or do y'all have to, is that just for y'all to track it?
It's for us to track and make sure we're doing everything. We can give that to Gerschlauer because it's their inspections.
Yeah.
There's no proprietary there between us two.
I don't know if it was a handshake so they could see, hey, they didn't do their PMs this week, so we're gonna call somebody
No,
and do that.
no, they give it to us and we have to abide by it.
Okay.
As long as we abide by it, those inspections and those manuals are our Bibles.
Yeah.
In essence, we have to abide by it or we take liability.
Yeah.
And Dollywood is not in the business of taking liability when it comes to these rides.
Yeah.
So that's why we are very stringent on the inspections. You can ask Mr. James here, I'm kind of picky on stuff. If I see something that is getting even close to being to its wear limits or anything of that nature, we change it. We never want something to go to its wear limits or past it. We want to be proactive, go ahead and get it changed, and then we move forward. Yes.
How long does it take to take a car apart and put it back together?
So, very good question. Right now, because we're not in a rush to get that vehicle back, it's been down there for about 3 weeks. We should have it back in probably another 2 or 3 weeks. But in the wintertime, we on average do 3 to 4 rebuilds on vehicles in the wintertime. And those cars get, all three of those cars at least get rebuilt in less than 2 months. So there's a whole team down there. We even give them a guy or two from the Mystery Mine crew to go down there and help them with those rebuilds to get them turned around as quickly as possible. So we stay on schedule for the 4th car to be rebuilt after we open.
So that's a separate team that does the big rebuild.
That is correct.
And not y'all on the day-to-day.
Correct. Any other questions?
In the off season, do you ever take the wheels and make sure like they're round?
So that's actually on a daily.
Okay.
We actually do function tests on our wheels on a daily, which I will show y'all downstairs when we get down there, because that's what we're going to next. And I have a vehicle down there for y'all. That's actually on a daily basis. When we roll the cars forward and backwards, we feel for lump, anything like that. We feel for bearings going bad, anything like that. So, a very good question. Yes, sir.
The actual track itself, does that get inspected?
On a daily basis.
Daily?
Yep, that's one of the reasons why I'm so sweaty this morning. We actually had to change out 3 of our friction wheels at brake 2. 1 at brake 2, 2 of them at brake 1. We had to change out 3 of those friction wheels. Now, thank God, those are lightweight. They are air-filled friction wheels. Everything out in the ride, those friction wheels that you'll see across the track are all air-filled tires. Everything inside of dispatch here and all the way out there are foam filled. This is for safety reasons. If we lost air pressure in the tire or in one of the tires, the risk of a vehicle coming forward and doing what you were talking about, bumping, is a great risk. So we have a third-party company, which Gerschlauer has approved. We have a third-party company come in. We ship the tires to them. They tear the tires apart because the foam is actually quite nasty. And they tear it apart, clean the rim up, put a new tire on there, actually drill a hole in the tire for relief for when they're filling it with foam. And then once it has sat for 24 hours, they ship the tire back to us and we can put it on the ride. So if they don't drill that hole, it makes a glorious mess because they did not do that one time and the tire literally ruptured in their floor from the pressure that the gas has built up from the foam expanding. So I heard it was beautiful. Yes?
Has a car ever bumped into another car?
Yes, it has happened, and that is why we do so much testing to make sure whether it is raining or it is dry, or if it's going to do both, we try to make sure that the vehicles are parking properly in the dock here to ensure that they do not bump each other. While the inside here, the bumps are not very hard, we still don't want it. That's the last thing that we want. It's not a part of the ride, it's a safety issue, so we do our very best to ensure they are spaced out properly when parked, so that if it does rain, it does not slide too far forward and make contact with the other vehicle.
If they do,
You were talking about like track inspection, so in the places where it's like over or like it goes upside down or whatnot, are you guys just, is it mostly a visual inspection?
Correct. It is on the track for the daily, weeklies, and monthlies. It is all visual inspections. Annually, you can ask Mr. James, this is the fun part. Annually, it is 100% torque check on column-to-column connections, track-to-column connections, track-to-track connections. Full value torque checks on every single nut and bolt on the ride. Right now, it takes us about 3 weeks with two-man crews doing it. It takes about 3 weeks to do them all. Yes,
How
ma'am.
many nut and bolts are there?
I have no clue. I haven't counted. I really don't want to count, but there's a lot. There's a great deal amount of bolts and we use a different colored torque stripe every year to ensure, hey, what color did we use last year? Red. Why do we have red all over the place? It should be a different color. So that's what we do. We use a different colored torque stripe every year to ensure that we have hit every single bolt all the way around the ride.
if y'all do get a bump, do you pull the car to have to check your limits and everything?
No, normally if we have cars that do bump together, it's normally something up here on the track itself. The friction wheels need to be adjusted, anything like that. Or it could have been an error on our part. If we're in maintenance mode, it's very easy to unfortunately hit the wrong button, and hey, position 3 just bumped into position 2.
Yeah.
So we're very cognitive when we're working on the panel. One of the things that I always ask the mechanics to do is when you're going to be moving cars, whether there's anybody up here or everybody's up here, holler out moving cars. Because if an operator or somebody has squatted down right here, I can't see them from the dispatch booth.
Yep.
So I want everybody to know I'm getting ready to move vehicles around.
Yeah.
Same thing when we're getting ready to ship vehicles, because I cannot see my entire perimeter, and I have multiple doors that have access to the ride, multiple gates that have access to the ride. We normally make an announcement over the PA system for the entire ride that we're getting ready to ship vehicles. Please exit the perimeter or be in a clear area. So sometimes we do have to be in the ride in order to listen and watch for certain things around the ride. It is not something we do very often, and it's only if we know there's an issue, then we go and investigate. Any other questions? No?
What's your tolerance for how wet it can be before you can run a ride?
So, per Gerslauer says a heavy downpour or heavy rain. What is the definition of heavy rain? So it's actually at operations discretion on when to shut the ride down because of heavy rain. That's why we try to make sure we even look at the daily forecast of what it's going to do today to see how we need to make adjustments inside here to try and ensure we don't bump vehicles or we don't have position faults. There are proximity switches at the back of the position and at the front of the position. If we don't come far enough forward, it'll fault out saying the car's out of position. If we come too far forward, it will give us a fault saying the car's too far forward. So we like to be pretty much right in the middle of the proximity switches. As long as we can maintain that, that gives us a little bit of leeway forward and also a little bit of leeway backwards depending on the weather.
When you do those tests like that, they're mass dependent. Do you load up the seats with weight when you do those?
No, sir. We actually do it with them empty, because when we do it with it empty, we have a good idea of where we want to be for when it is loaded.
Okay.
So what I tell these guys is actually there's 2 friction wheels for this position here. I want, which y'all will see downstairs, I want the front of the skid plate in the middle of the front tire. So where the middle of the tire is, that's where that skid plate should be sitting. If that skid plate's forward and already starting to pass the tire, we need to raise the rear tire to slow the car down. And that's the way it works. Two friction wheels in the position. The rear tire slows the vehicle down. The front tire stops the vehicle when it gets in position. So that's the way it's designed.
Follow up, how much does each car weigh?
5,000 pounds. Then plus the weight of the guest. So if you've got husky boys like me, because I am right at the hairy limit of getting the restraint down, it's kind of like, yeah, there we go. And I'm 285 pounds, so if you have 8 people at 250 pounds, that's 1,600 pounds. Yep. Yeah, something like that. It adds in there somewhere around 1,600 more pounds to the vehicle. So now your vehicle weighs 6,800 pounds. And you'll see downstairs what element actually is what pushes the car up the lift hills. And you'll be quite surprised on how small it is. It's got your road wheels, which is just like your car tires on your vehicle. Keeps the vehicle on the road, on the top side of the seal. Guide wheels, that helps it get around the track on the curbs and everything. Upstop wheels, these keep the car on the track when it's upside down or in zero G moments. You really like these when you're on the lift hill. These screws here, you can see here, these are how we adjust the tension on our guide wheels. More tension on our guide wheels, slower the vehicle goes. Less tension on the guide wheels, faster the vehicle goes. So it's where Gerslauer says 2 turns in on these bolts once you get them touching, and then make adjustments after that in order to keep maintain your speed around the track. Normally, we want to, our normal track time is about 117 seconds from brake 4 to brake 9. That's where we normally like to keep it for an empty car. Once you put guest in there, that drops that lap time down normally by 3 to 5 seconds. That's how much time it shaves off. So normally we're down to about 112, 113 once we have it loaded. So, but underneath the car, which you all can come underneath the car here in just a minute. Underneath the car, you have the skid plate on the backbone of the vehicle underneath there. It's held in by rivets. You have magnets underneath the cars. I would suggest not getting your phone, cameras, anything like that too close, including watches or anything like that. If it is electronic, it will scramble it. One of my mechanics, we were actually changing out one of the magnets here because of some damage that got done to it. One of my mechanics decided to sit down on the magnet, and every card in their wallet got wiped out. So they had to order all brand new credit card, debit cards, including driver's licenses, because Tennessee has the magnetic strip on the backside. They had to order everything, all brand new. So the magnets are very strong. They are rare earth magnets. I can stick a wrench up in there and let the magnet grab it, and some of our smaller operators can't even pull it out of there. That's how strong the magnets are. Now the brake fins that we use throughout the ride, which you will see here in just a minute when I take you inside, are a composite. They're anywhere from copper to aluminum brake fins, depending, and an alloy, depending on how much force we want to apply to the vehicle to control it and slow it down. So we have different components on the ride that are also fixed brake fins, trim brakes, and automatic trim brakes. And I'll show you all that here in just a minute and how those work. But back to the car here, you can also, when you get under here, you can see where the seat frame bolts are mounted. And then underneath here also, you have what are called ARB arms, anti-rollback arms, and you have a chain dog arm. You have 2 ARB arms, one on each side. Chain dog arm is in the middle. The chain dog arm is what engages, what is engaged by the pusher on the lift hills, which I will show you all that here in a minute. That pusher is what pushes the car up the vertical lift hills. It's different from, like Fire Chaser, Tennessee Tornado, Thunderhead. Their chain dogs actually fall into the chain and captures one of the links. Ours, on the other hand, has a pusher that is 2 pushers that are equally out from each side on the chain that grabs the car and then takes it up the lift hill. So the chain, when you do ride this, you'll realize when you come into the base of the lift hill, chain's not moving. The pusher is sitting actually at about the 10 o'clock position on the idler sprocket, to where when the car is in position, PLC sees that it's in position and parked, that pusher then comes up, captures the car, takes it up the lift hill. So it's a little bit different compared to what Like I said, Fire Chaser, Tennessee Tornado, Thunderhead, all of those. So, but you'll see that actually underneath here. And then, let's see, what else we got underneath here? And then actually I have on the table right here, I set up some things to show y'all what we deal with and whatnot. So you see, y'all can come by as you go.
I had one of those at the auction yesterday.
So we have different types of wheels here. You see the white ones here? That's this guy, that's a nylon material. Those are to help with speed of the vehicle because a urethane tire grips the track. It actually grabs a hold of the track and slows the vehicle down. We use nylons, 2 of them on each side for the guide wheels, and right now 1 nylon road wheel on each side of the bogies on the rear in order to keep our speed up. If we were to use nothing but urethane tires, we would be going way too slow. Vehicles most likely would not make it through the corkscrew and loop, and that is no fun getting those vehicles off when they valley. Ask me how I know.
How do you?
I've had to do it twice in 72 hours.
Oh my god.
Yeah. So it is no fun. We got it down real fast. We got it down pat pretty quickly though. But it is absolutely no fun to do it because you actually have to drop the brake fins and then also an entire bogie off of the or the guide wheels and upstops off of the car in order to get that vehicle back up there and get it off the track. So because the way the bogies are designed, it actually has a half moon shape where the guide wheels and the upstops attached to where if we were to lose the upstop wheels or the guide wheels, the vehicle would still stay on the track. It would be a very rough ride, but the vehicle would stay on the track. So those are the different types of wheels. And this wheel here is actually a failure. And what the failure is on this wheel is actually delamination. As you can see, and I'll just leave my knife in there for y'all to see, the wheel, the urethane actually failed the glue that bonds the wheel to the rim. That bond failed. And we don't see this very often, but that bond failed and we found it on a daily inspection, so we changed the wheel out. Changing the wheel out takes about 10-15 minutes. It is 2 bolts holding the entire axle in. Take those 2 bolts out, take the cap off of that side, have the entire bogie jacked up a little bit, and then remove the axle, pull the wheel out, put the new wheel in, throw the axle back in with a little bit of lubrication, and then put all your hardware back together. None of the components on these rides are cheap because of the testing and everything that Gerstlauer does. Gerstlauer does a great deal of testing on these components to ensure that they are going to work the way they work. Like I said earlier, I'm from the aerospace industry. Aerospace industry safety factor is usually a 1 to 1.2, 1 to 1.3 because of weight. Here, weight's not a matter. These have a much higher safety factor. Normally 1 to 4, 1 to 5. A much higher safety factor. They can take a great deal of stress before they break. And that's just due to people neglect the ride. We do not. If we find a crack on the chassis, that car is down until the crack is repaired per a weld procedure from Gerstlauer. We do not just go welding willy-nilly on the vehicle. We have to do it by the weld procedure that Gerstlauer gives us for any repairs. Any other issues that we find on the ride, excuse me, any other issues we find on the ride, we have to get with Gerstlauer first in order to figure out what we need to do in order to get the ride back operational or that vehicle back operational. And normally Gerstlauer has 20 questions when they reply back. Hey, how did this happen? What was the conditions? What was this? What was that? What was going on? So we have to answer all those questions for them to give us an answer back. So they have to have a lot of factors to know what's going on. So, any questions? Yes, ma'am.
Some of the rides are a little more violent and shaky than others.
Yes, ma'am.
Would that be the side wheels, the guide wheels, or just... Yeah.
So it's a little bit of everything. You're trying to take a square box on a round track, around a corner. So, and these are spring loaded. So it fights itself a little bit going up there. We actually, because of that issue and another issue, we reprofiled Mystery Mine from brake 5, where the trestle is, where it goes over top of the pathway. We reprofiled that. We took out one of the better elements that I thought. The horseshoe, the lateral horseshoe, and then part of the figure 8, and opened it up we opened up that figure 8 part in order to relieve some of the stress on the vehicles. Because okay, so the door that you just came through is actually right above you is where the ride dispatches. Right above your head is actually brake 1, brake 2. The track stays up high, comes around the corner, drops, and drops down into brake 3 here. Brake 3, what you see here, is a stationary trim brake fin and an automatic trim brake fin. Somebody asked, how do we control speed on the ride? These proximity switches that you see right here, all 5 of these, are actually high enough to read the holes in the brake fins. If you looked on the brake fins, there were slots in there cut. These are actually reading how fast those slots are going by. And it's calculated in milliseconds. Michelin was manufactured in 2007. 17 years old this year. 16 years old this year. Yet, it measures everything in milliseconds. If it doesn't see something in a certain amount of milliseconds, kills the ride. Shuts it down right then and there, stops vehicles when it comes into the safety brakes on the lifts. This is not considered a safety brake. This is just how it controls speed. So as the vehicle is proceeding by, it's saying, hey, you're going too fast. I'm leaving this brake up and in place. As it's going through there, it'll get into these proximity switches and goes, okay, you're going slow enough. This guy drops out of the way and no longer impedes the vehicle to where it can then go around the track here, up a little incline, and into brake 4. Brake 4, which you will see, has another stationary trim brake. Certain brakes have just stationary trim brakes. Certain ones have automatic and stationary, and some just have automatic. So it just depends on how much control of the vehicle Gerstlauer dictates to keep the vehicle under control. Because we don't want it flying off the rails. That'd be a bad day. So, it's all controlled pneumatically. The PLC sends a signal to this cylinder underneath here. This cylinder then reconfigures its valve, drops this guy out of the way. Once the vehicle gets into and clears brake 4, then this trim brake will come back up. But it'll stay out of the way until the PLC knows that that car has entered and exited brake 4. If you look at each one of the places where the safety brakes are, you will see 2 proximity switches in front of it, or on the back side of it where the car's coming in, and 2 proximity switches at the end of it. This is a redundancy system to where it knows that it's in the brakes and it knows that it's coming out of the brakes. If one of the proximity switches fails, it then shuts the ride back down to where it stops everything, say from brake 4. If we have one proximity switch fail, from brake 4 backwards, from here all the way back to the station, shuts down. Everything past brake 4 keeps going because there's nothing in that area indicating that there's a problem. The problem was at brake 4, so it doesn't want any other vehicles coming through that area. So that's what we call a block shutdown. That's where it just stops everything from that point backwards to the station. No dispatch is possible. It gives us a fault on the screen. Operations then calls and says, hey, ride's 10-7, we've got an fault. That's when we come up, determine what the problem is, if we can bring the guests home that are on the vehicles, or if we need to have operations go out and get them. Gerstlauer actually prefers us to bring the cars home if we can. It is safer for you to go around on the track as long as the track is in good shape. Nothing's wrong with it. We determine it's just a proxy that falls it out. We can get these vehicles moving. Gerstlauer would rather those vehicles be brought home and the guests be taken off up on dock than to take them off on the platforms. It's safer. So, any questions for this area? Yes, sir.
Manual controls over here, is that, have you guys tested?
No, sir. The manual controls that he's talking about that they walked by over here, that is actually how we clear block shutdowns. Each one of the safety brakes and each one of the lifts have what are called a jumper safety distance key. It takes normally 3 mechanics to clear blocks on a mystery mine. You have to do what's called a source target. What that is if we have a car, say on break 5, outside here on the top of the trestle, if we have a car and block shutdown at break 5, we have a source, which is break 5, and the target is break 6. So 2 mechanics out there turning their keys, also clearing, making sure everything past it is in good working order, and then a mechanic up in dispatch turning a 3rd key for a jumper safety distance. This now has 3 keys being turned, ensuring to the PLC, because the PLC can't see everything, it's ensuring to the PLC that everything is in good working order, that you can release that car and let it proceed on. That's how our process has to work. We have to ensure that everything in front of the track is clear, that everything where the car is stopped is in good working order. We can send it and then send it. We are telling the PLC that it's good to go. Any other questions?
How often do the proc sensors go bad? Or do they just examine them?
We call it flaking out.
Okay.
When they start flaking out and giving us bad signals, but that is very rare.
Okay.
It just does not happen very often, and when it does, it's actually a pretty quick and easy fix. The base is actually separate from the proximity switch unit itself. If you look on these, the base is black. The proximity sensor itself is green. 3 screws, take those 3 screws out, boom, the proxy comes off. Ensure that the proxy or the sensing head is facing in the direction that needs to face. Put the new proxy backs on, put 3 screws in, you're done. That's how easy it is to change out, unless we have corrosion on the inside of the electrical connections. If we've got corrosion on the inside, then we need to change the whole base unit out. And for that, we bring in our control electricians, because it requires rewiring. Even though it's 24 volts, if you rewire it incorrectly, a normally closed or continuously looping proxy that actually opens when a vehicle comes by and senses something will actually be then reversed, and it'll be constantly open. And it'll freak the system out. It doesn't like it. So we will then bring our control electricians in to change out the base to ensure that it is done correctly. Put the proxy back on, and then we will run several test cycles to ensure that it is working properly. You had a question?
So, pneumatic cylinder here. So, pneumatic cylinder is used to pull the thing down.
Correct.
That means if loss of pneumatics, thing is stuck up, the car will go by.
Correct. They're spring loaded. So, that's a very good question, and we'll actually discuss that a little bit more over at break 4. Everything is designed on this ride to where if we lose electrical or pneumatics or air pressure, it is designed to stop the vehicles. So, if we lose pneumatic pressure, this brake fin is not going to drop. It's got springs holding it up. The safety brakes that we'll be seeing on brake 4, they are pneumatically held open. Large spring on the inside that is then compressed when it is open, to where if we lose air pressure or we lose electricity, it immediately shuts. And when I say immediately shuts, in a blink of an eye, that brake is closed. It is extremely fast, to where I tell my mechanics, if you're messing with that brake better be off, and it better be shut down and not open, because if it's open and for some reason it comes close and you got your hand in there, you got hamburger meat for fingers. Because it has that much force to be able to stop a 5,000-pound vehicle plus the weight of the guest. And our brake runs, brake 5, brake 6, brake 7, brake 9. When a vehicle is in block shutdown, we want at least 1 car length of brakes ahead of it when it comes to a stop, to ensure that if our brakes are wet from rain, that it has enough space to slide forward and still come to a stop. Now, we have gotten into situations where an issue has happened, and it happened right in the middle of the brake run. They slammed shut, but the vehicle slid further forward than what we're comfortable letting gas off of. So we actually have to tie the vehicle back. We go around the frame with a strap. We then take another strap and go back to one of these I-beams for our track-to-call connections and tie it back to there, to ensure the vehicle will not slide forward while guests are getting off. Brake 8 at the top of lift 2. Every time we have a stop up there and we have to get guests off, has to be tied off. Because it is sitting at a slight angle, even just a little bit of rocking back and forth, it's going to slide a little bit. Those brakes can only hold so much, and it will just slide forward very gently forward, and we don't want that. We want that car secured to where when our guests are getting off, they don't feel it moving, and we know the car is going to stay in place. After we get all guests off and operations have closed the restraints, then we untie it, and then we work to bring it home. We have to maintain a less than 5mm gap in between those pads in order to apply enough pressure to the 6mm thick brake fin to stop a vehicle here. The brake fins on the track itself will not stop a vehicle. They are just there to control the vehicle. The beams are here to stop it. That's why this brake right here has 2 sets of brake beams. It comes in here, it senses something, they slam shut, stops the car right here. Like I was telling you earlier about the friction wheels, this friction wheel here is air filled. Much easier to change out, much lighter, weighs about 30 pounds. The foam filled friction wheels in the dock weigh about 90 pounds. Those are fun to change out. So, that's what we use here. On these wheels, we are allowed to go down to the wear bars on the wheel. If you ever look at the car, the tires on your cars, they have wear bars in between the tread. You're supposed to change the tire out before you hit that wear bar. That's the same concept here. We cannot go past that wear bar. We have to change it out before we hit that wear bar so that there's water on the skid plate or water on the tires, it doesn't affect it as much. A slick tire does not do well with water. It just makes it go whoo, right past it. It's no good. That's why we change them out when we hit that. But this is brake 4. These are the cylinders underneath here. That guy right there and that guy right there. Those cylinders right there, like I said, pneumatically are open, spring-loaded to close. If we were to lose pressure, if we were to lose electricity, if we were to have a fault, they're spring-loaded to close, shut very fast. Friction wheels shut down as well. Sorry. Friction wheels shut down as well. So, remember I was telling you about coming into the brake area and coming out of the brake area? Those are your 2 proximity switches right there. That's coming out of brake 4. Those proximity switches back there are the ones that are saying, hey, it's coming into brake 4. The PLC knows where every single car is. On the lift hill, there's actually zones on the lift hill. You have the curve up, that's one zone. The vertical part, that's another zone. And then the top of the crest, that's another zone. Then it has a set of proxies at the end of the crest that tells it that, hey, the car has cleared the lift hill and it's heading towards brake 5. Same thing with brake 8. It does the exact same thing. So I was talking to y'all earlier, about the chain dog and the pusher. That little guy right there is all that pushes you up the lift hill. It is not much, but it has been engineered and designed. That has never been changed out. It lasts a long time. It actually gets on an annual, it gets ultrasound. And to ensure everything inside mechanically and structurally is good on the inside of it. But that is our pusher. There's another pusher symmetrically out on the other side of the lift chain at the top of the hill. So that when the chain does a full cycle, the next pusher ends up right in that position. And if it's out of position, it will fault out and let us know. Then we gotta fix it. So, you have what's called the bridge here. That's where the car comes over and pushes the chain dog up because we don't want the chain dog dragging across the chain itself. You damage the chain dog and you damage the chain. Car parks here. These 2 little brakes right here, these are called frog brakes. These little frog brakes right here is what keeps the car from rolling backwards when it's trying to go up the lift hill without the pusher. Inertia brings it forward. It gets to a certain point, once it starts going backwards, These little guys are actually on the brake fin and grabs it. Those are rubber pads on the inside there. Just grabs a hold of it and stops it. Keeps it right there until the pusher comes up and engages, then takes it up the lift hill. The ARB arms, the ARB rack, remember I was telling you they're offset? You can see that right here. They're offset to where one valley is in the tooth of the other side, so that it's the minimum distance of falling. Now only one ARB arm will hold you up if something happens to the chain. Only one. That's it. The other one's not engaged. It's sitting on top of one of the teeth. So, that's how it's designed, and I'll tell you this, it works very well. Which we were able to figure out what the problem was, got it resolved, and the rest of the day. It just took a little time for us to figure out what the issue was.
Okay.
Any other questions? Yes, sir. What part? I'm sorry. The pusher is steel. Yep. No, sir. No, it's a steel. It's steel material. The brushes are for, remember that little arm on the ARB arm? That's what the brush is. That's where that's called an ARB lever. It rides those brushes to keep the ARB arms out of the teeth as much as possible. Yeah, kind of. By the time a fully loaded car gets down to the bottom of the drop, it's about 45 miles an hour. 2018, we ripped out River Battle. That's the closet now that you have up there. I then was left to become foreman of Mystery Mine all the way down to Thunder Bay. So I have all 5 lots in this area.